Okay. So since we've already talked about these two chapters, if you remember, we've done until motion, right?
Yeah.
Okay. So the next one that comes in your syllabus is about force and how force causes motion. So have you done this? You've done this chapter, right, before in your class?
Yes.
Okay. Okay. So what do you understand by force?
Not much.
Okay. Even in the regular terms, if I have to ask you, like even if we have to ask, like in general, in day-to-day life, what could be force?
Something that like pushes, maybe.
Okay. Okay. Absolutely. One second. I think I just need to inform them that. Okay. So you said that pushing, right? Okay. What about pulling?
I guess.
Okay, great. You're right. Okay, anything of this sort comes under the category of force. But what exactly is it, or why are we talking about it? Is because force is something which is responsible for an object to come in motion. Like, for example, your table, where you're sitting right now, I mean, where you've kept your laptop and everything, that's at rest right now, right?
Yeah.
Suppose if you push it, it'll start moving.
Yeah.
Okay. If you pull it also, it'll move.
Yes.
Of course, it will depend on like if it's very heavy, then it won't move. For example, if you push a wall, it will not move.
Yeah.
If you push a normal object, which is like small in comparison, it will move. Or even when you're pulling something, it will move. Force is a quantity that helps, or it's like pushing or pulling an object, because of which an object can come in motion, or the object can also like if it was moving. Suppose if there was this ball that was moving in this direction. Okay. Can you apply a force so that it will come to rest?
If you do it like the opposite.
Very good. Yes. Or even if you put your foot like this here, it will stop. So, so force can also make a moving object stop. Okay. There's one more thing that force can do, and that is it can change the direction of an object. For example, when we play any of these games like cricket or badminton or hockey, all of these games, when we are playing, what are we basically doing? When we strike, what happens? It changes, right? The direction. So force can also change the direction of an object. So what did we see? That force can make an object move. Force can stop a moving object. Force can also change the direction of an object. Suppose if there was, I'll give you one more situation wherein there was a ball that was already moving in this direction. Suppose you apply a force in the same direction, what will happen?
It'll go faster.
Very good. So if you remember, when we had talked about anything that goes faster or slower, we learned a topic called as, or we learned a word called as acceleration. Do you remember that?
Yeah. Yes.
Like how car accelerating and everything. So force can also make an object accelerate, right?
Yeah.
So we'll see this now. Force, this is like a summary, okay, of whatever we spoke about just now. So it's saying that force can be represented by arrows. Like I was doing these arrows right here, that you're applying a force like this. So because force is a vector quantity, you remember I told you about scalar and vector quantities?
Mm-hmm.
Vector is the one which also has a direction.
Yeah.
Force also has a direction, and therefore force is represented in symbols. It can be represented like this also, which means that force is a vector quantity, and that's why the arrows. Okay?
Mm-hmm.
The direction of the arrow is the direction of the force, in whichever direction the force is acting. Like if the force was acting like this, then the arrow would show that. Okay. Now force can make an object change its speed, which means it can accelerate also, and it can also stop an object from moving, which we already discussed. Force can also change the direction in which the object is moving. So all of these things you've understood about force, right?
Mm-hmm.
Okay. Now, see, whenever we discuss any quantity in physics, it's also important for us to talk about its unit. Okay. So now we'll just briefly talk about that. You've understood what force is. Now we saw that force is a vector quantity. Okay. And do you know what's the unit for force?
No.
Like how you represent mass in kilograms or grams. Then you represent speed in meters per second or kilometer per hour. Like that, how do you represent force?
I don't know.
Newton, N.
Okay.
Okay. So, like for example, a force of 5 Newton is being applied. Okay.
Okay.
That's what the unit means here. Now, force can be of various types. Like, because we are going to be talking about force a lot in this chapter. So what you also need to know that force can be of various types. So first, let's just look at the various types of forces, okay? The major category for force is contact and non-contact force. Like as of now, in whatever examples we discussed, like, when you were pushing a table, or you were kicking a ball, or you were playing, let's say, hockey with your hockey stick, any of these cases, these are all examples of contact force.
Mm-hmm.
Okay, now what is contact force? You must have understood by the name itself. Whenever there is physical contact, like when you're pushing something, you have to touch that object to push, right? You cannot, like, you don't have any superpower to push an object just like that. So these are all called as contact forces. Now, I'll give you one more thing about, do you know what's friction?
When you like rub together?
Yes. So whenever two things rub against each other, there's something called as friction. Even when you're moving on the ground, let's say you're walking on the ground, okay, on the field or anything, there's friction between your shoes and the ground also.
Mm-hmm.
Okay. So that's friction. That again is a contact force, because that can only happen because your shoes are touching the ground. Or even when you're rubbing your hand, you're actually touching your hands, right? That's why there is frictional force. Mechanical force means pushing and pulling an object.
Okay.
Okay. Like whenever you're, so for the, like in this example, the boy is taking out water from the well. So he's kind of pulling that rope so that the water can come out in that bucket. So it's a push and pull force. Muscular forces, whenever you try to lift something. So you'll use your muscles strength. That's why, you know, those with good muscles can lift heavier weights in the gym. So that's muscular force. But all of these, whatever examples we saw right now, these are all types of contact forces. Okay.
Yeah.
Now, but there are also some forces which can also act on an object even when there is no contact between them. A very simple example, if you have iron nails and if you take a magnet, you don't need to touch that magnet to those iron nails. Even if you bring it very close, what will you observe? That the iron nails will get attracted towards it, right? This is something that generally happens. Or suppose when an apple is falling down from a tree, then we say that it happens because of gravitational force, right?
Yeah.
So gravity also acts in which direction? It acts in the downward direction, but do you like need to be in touch with the earth all the time?
No.
No. So gravitational force also can be acting without like being in contact. Okay. And there is also something called as electrostatic force, which you will understand once you go further in the chapters. That is electricity kind of a thing. So in that also, it's not necessary for objects to be in contact with each other. Okay. So there are these two types of forces that we saw, one which could be contact forces and the other one that can be non-contact forces, in which the physical touch is not important, that's non-contact, and where physical touch is important, that's contact. Okay.
Okay.
Now, see, when we were talking about pushing and pulling an object, there's a specific case that I want you to think about. Okay. Let's suppose a case of tug of war. Have you ever played tug of war?
Yeah.
Okay. So you know that a tug of war is wherein there are people on both sides trying to pull.